Hi everyone, welcome to this video on solids, liquids and gases. This is the 7th lesson in the particles and energy scheme, and it's the first lesson where we really talk about matter and go into depth. So we had one lesson towards the beginning where we talked about this much broader idea that scientists have guessed that if we break matter down enough, we get down to these really tiny particles called atoms. Now we're going to look in a bit more detail at that particle model and the three categories with which we make sense of all the matter that we find in the world and in the universe. Not quite in the universe, we're not going to go into dark matter right now, but this is year 7 after all. So I think it's nice here when teaching this lesson not to just go straight into the particle diagrams. And by the way, it's worth remembering that students will probably be familiar with these particle diagrams. They will at least have seen these at some point during primary school, even if they may not remember all the details. What we're going to do is give them a few more details and really bring together these ideas of particles and energy, or matter and motion. But I think it's nice to start concrete and just remind students that what scientists are doing when we talk about solids, liquids and gases is we're trying to make sense of this really messy, complicated, diverse world where there's lots of stuff. And by placing these categories on the world, we're just trying to make it a bit easier to understand. So I might start by telling them a story. So I'm going to imagine there is a person like this. Now, this does not need to be a work of art. A stick person is fine. And they're standing outside their house, like this. And I'd probably get students to draw this with me, although you don't want to take too long over this, so make sure they keep it quite simple. Maybe they've got a water bottle in their hand, made of metal. And you can just tell them this, I don't think we need to label it right now. They've got a football by their feet. Seems to be a rather large football compared to the size of the person, but that will do, that's okay. And there's going to be a car driving past, like this. And I like to draw little cars like this. But again, it doesn't need to be a work of art. If you want to draw just a box with a couple of wheels or something, that's fine. And you could add some other details to this. You could say there's a tree there or whatever. But really the idea that we want to get across when we present this diagram is that we're starting with the world, and scientists always have to start with what's out there, and what they're trying to do is impose categories on the world to make sense of it, just to make it easier to understand. And what I'm going to say to my students is, well, okay, there's all of this stuff in the world, and we need to try and think of all the matter that makes up this stuff that we can see in our picture, that we can understand. How could we categorize that matter? And actually, like I say, students will be familiar with these categories, so they might even know already, especially because the title of the lesson is solids, liquids and gases. So you might say, okay, let's look at a few of these things. Let's look at the bricks that make up the wall of a person's house. Let's look at the person's body. Let's look at the outside of the football. I'm going to draw these little boxes for reasons that you'll see in a minute. Let's look at the metal that the car is made out of, or indeed the water bottle is made out of. Now, if we were to look at all of those and go in with kind of a giant magnifying glass, now obviously the giant magnifying glass, the physicists will get very upset about this, because obviously you can never see down to atomic level with a magnifying glass, but we can kind of tell them that. Remember, our model of science is trying to understand things that we can see in the world in terms of things that we can't see. So what we're doing here is saying, well, all of these solid things, the bricks, the person, the outside of the football, the metal of which the car is made up of, all of these are solids, and they are kind of hard and firm. You can't kind of pour them. They don't flow in the way that a fluid does. And all of these have something in common. And the way we understand this is in terms of the particles having this sort of arrangement. So what I'm going to do is show what the particles would look like in a solid. So I'm just going to sketch these. And again, you guys will all be familiar with this. This is bread and butter to a science teacher. So I don't need to spend too long on it. Now what I'm going to do is show this regular arrangement. You want to make sure you emphasize to the students that the particles shouldn't be overlapping and they should be roughly the same size and so on. My particle diagrams don't always tend to be the best, but they should get the idea. And you want to show them that there's this regular arrangement. And you'll see in the slides here, and this is actually really taken from the GCSE spec, but I don't think there's any reason why we can't introduce this in Year 7 with some well-chosen diagrams. What we want to talk about is the arrangement of the particles, which I've done here. So we're going to describe this arrangement as a fixed lattice. And that's new language that you will need to teach them, and you might want to get them to say it as well, because they need to be familiar with what we mean by that. So remember, we want to emphasize that fixed means they don't move, and a lattice means they have this regular shape. So we've got this fixed lattice arrangement. In terms of their motion, they vibrate, or they jiggle, as Richard Feynman likes to say. They vibrate or they jiggle on the spot. So I'm just going to show that with these little lines around here. And later on, we're going to see diagrams where the more kinetic energy particles in the solid have, the more lines I'll draw for their vibrations. But right now, just one line is fine. That's just to show that they're kind of jiggling around. So they're fixed, they don't move, they only vibrate, they're in a lattice, this regular arrangement. And you might want to talk about the energy that they have. So they have relatively low energy, and you might add that there are strong bonds between the particles. So I might add a note here just to say strong bonds. We're giving them this really simple picture, but I think what's important is we're trying to emphasize a lot of this through the diagrams. We want our diagrams to do a lot of work. So then I'm going to think about, okay, maybe the water, the water inside the water bottle. Maybe I'll think about the petrol that we put in the petrol tank in the car. So I'll put a petrol tank in there. Anything that flows, you might say cooking oil inside the house. If it rains, rainwater, whatever. I'm going to draw another box here and show my second category of stuff. And again, you guys will all be familiar with this. So I'm going to show students that actually they're still very close together, but this time the particles are going to be randomly arranged. There's no particular order to them, like this. And I'll try and keep the same number of particles here. So I've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I just need 5 more. So I'm going to show these all together. Again, they're never overlapping. I think I've got the same number here. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Perfect. So again, what I want to show now is this random arrangement. So where we had a fixed lattice before, now we've got a random arrangement. And again, that's a word you're going to have to give to students, and you're going to have to quiz them on to make sure they remember it. And you also want to show the random motion. And I'm going to show this with these small arrows in different directions. And I want to emphasize two things here. One, the fact that the arrows are all in different directions, hence the random motion. But two, it's also worth emphasizing, and we'll come back to this in the next lesson on temperature, that the arrows don't all need to be the same length. So the particles move with a range of speeds. And what's important, as we will find out with the students, is the average speed or the average kinetic energy, because that's to do with the temperature. And in terms of the bonds, I might put in here, well, they're close together, so we've got some weak bonds, but still relatively low energy, or really I should say kinetic energy. Okay. And then the last one, you guessed it, I'm sure, we can think about the air that we breathe. Maybe we can have some fumes coming out of the exhaust pipe of the car in there. Maybe the air inside the football, if we want to be creative. We can emphasize all of those things in our picture. And again, we're emphasizing that we are placing these categories. We have decided these categories based on what we see in the world around us. So that final category of stuff, well, that's gases. Again, nothing new here. What's this going to look like? Well, we've got particles now, they're much further apart, and they're still randomly arranged. So they're a bit all over the place. And we've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I'm going to show them all over the place like this. You might want to do some quizzing here, so you might want to sort of do a thumbs up, thumbs down questioning and say, would you expect the particles in the gas to have more or less kinetic energy than the particles in the liquid? Hopefully they'll recognize that they're going to have more on average, and that's something they need to remember, that the particles in the gas have the most kinetic energy. So I might add it like this. And again, we've got this random motion as well as the random arrangement, where particles are in all different directions and with a range of speeds. So again, emphasize the fact that the length of the arrow refers to the speed, because that's something we're going to keep coming back to again and again throughout their journey into physics. So I might put random arrangement again, and random motion. Maybe I should have added that note to the one before. So random arrangement. Maybe you could add a note about motion, although in this case, maybe we don't need to actually. Hopefully the different arrows shows that random motion. Also, they should be able to get from the length of the arrows that there's more kinetic energy here in the gas particles than here in the liquid particles. And what's worth emphasizing here is when we are thinking about the particle model in physics for gases, we assume that there are no bonds. We assume that there are zero interactions. So where we've got strong bonds in the solid, we've got weak bonds in the liquid, you can just put no bonds between the particles in a gas. Now, the only other thing you might want to add here is the changes of state. I don't always do this because it's quite a lot for them to take on. We should probably add some labels here like this. So you could add melting and so on. That's up to you whether you want to include that in the final deliberate practice task. Let's put gases like that. But just a reminder, really the purpose of this lesson is to get students writing about the properties of solids, liquids and gases, and there are those four main categories. So one is the arrangement of the particles, one is the motion of the particles, one is the strength of the bonds between the particles, and one is the kinetic energy of the particles. And if you can draw diagrams that do most of that work without you having to write too much, that's going to really help your students think about it and hopefully remember it later on. Next lesson, we'll be looking at temperature with lots of very similar looking diagrams.